So we're going to pick up where we left off with this graph. And if we move on to the next section over here, the next question, it says, what is the slope of the line you graphed above? I apologize, all this work disappeared. But anyways, we have the line from the previous video. And how do you determine what the slope is? You got to count how much you rise and how much you run from left to right. So you got to look at this blue line from left to right, not from right to left, but from left to right. So you pick 2 points, and the 2 points are very clear to be on the x-intercepts here. So from this point to this point, how much do you actually rise? Do you actually rise up, or do you rise in a negative direction? Up. So you rise 1, 2, 3, and you run 1, 2. So the slope, the m of the above line, is up 3 over 2. It's always rise over run. Keep in mind, the rise could be positive if it's going up, or it could be negative if it's going down. But we're going to choose to always look at lines from left to right, which makes it always a positive run. Okay? Maybe I shouldn't have put that right there. Let me erase that. Okay, anyway. Moving on. More slope here. Number 6. Find the slope of the line passing through. Okay, you guys haven't tried it. Let me pause it and you guys work it out. Let me see if we can get an answer. So to find the slope of the line that passes through these 2 points, we need to know the slope formula. In case you forgot, there it is. Slope formula. M equals y2 minus y1 over x2 minus x1. Notice that I put these in different color, red. The division bar and the subtractions are in black because I highly recommend you always start by doing the division and the subtractions and then plugging in your y1, x1, x2, y2 values. Now you might be thinking, where do I get those values? Well, they give you 2 coordinates. And what are coordinates really? They are x and y values. This is also an x and a y value. So if I told you, look at the x value. Well, you don't know if I'm talking about this guy right here or this guy over here, right? So in order to be more clear on this, we need to label one of the coordinates your first point and the other one your second point. I want to call this one my first point. I want to call this one my second point. And it doesn't really matter which one you call first or second, as long as you label them 1, 1, and 2, 2. What does the 1, 1 mean? That means that this is your x from your first point. This is your y from your first point. This is your x from your second point. This is your y from your second point. Anyhow, now let's go back to the formula over here. We're simply going to do the division bar and the subtractions. So you're going to have the slope will be equal to division bar and subtractions, okay? And now let's plug in the value that belongs up here, which is y2, and y2 is negative 6, and y1, which is 4, and x2, which is 2 up here, and x1, which is negative 3 right here. And of course, we have the minus minus on the bottom. That's the reason why I want you to do the division and the subtractions first, because once you plug in the values, then you'll see the minus minus that needs to be changed to plus plus. Anyhow, on top, we end up with a negative 10, and on the bottom, we end up with a 5. So your final simplified answer, m equals, you could put negative 2 over 1. That's great, especially because we're going to talk about graphs, or you could just leave it m equals negative 2. Whatever you prefer. Both answers are correct. Okay? Moving on to number 7. If anybody tried to do their homework last night, you might have run into some problems with number 3. Okay? It says determine the rate of change. We learned yesterday that rate of change is really just another way of saying slope, right? So they give you an equation, and according to the book, since we've only done standard form, they would like you to actually go through all the steps. Subtract 8x, rewrite that guy as negative 8x plus 6y equals negative 40. And then they would like you to change the sign of the a value by multiplying everything by negative 1. So if you were to multiply everything by negative 1, you'd get the new equation 8x minus 6y equals 40. And then the 8, the 6, and the 40, those all have a common factor. You could divide all those values by what? By 2. So let's divide them all by 2 to make it a little easier for us. You're going to have 4x minus 3y equals 20. Okay? That's your standard form equation. And now let's actually do an x-intercept and a y-intercept for this. So the x-intercept will be setting y equal to 0. So it's going to be 4x minus 3 times 0 equals 20. And the y-intercept will be setting x equal to 0. I'm not writing it down anymore. Hopefully we already know it. Y-intercept is to set x equal to 0. So that's going to be 4 times 0 minus 3y equals 20. And instead of continuing with this really long process of finding x and y intercepts to be able to graph the line, to be able to count how much you rise and how much you run on a line that's visual to you on a graph, instead of all that, we might as well go back to what we know from Algebra 1. You guys remember slope-intercept form? Slope-intercept form is y equals mx plus b. You guys remember that? Okay, do you guys know what that m is? Slope. So if they're asking for the rate of change, they're asking for the slope. And if you look at this original equation, it's almost in slope-intercept form. All I need to do is get rid of that 6. So what could I do? Divide everything by 6. So I could divide this by 6, divide that by 6, that by 6, and I will get y equals 8 over 6x, and then minus 40 over 6. Who cares? I'm going to leave it like that, 40 over 6. Now, my point is, if they're asking for the rate of change, they're asking for slope. And if you know slope-intercept form, then you know that this is a slope. So what would your slope be? 8 over 6. But you could reduce it 4 over 3. So the rate of change, the slope, is really 4 over 3. And this is a heck of a lot faster than all of this stuff. We didn't even get halfway done with all this over here. We still needed to do this work, do that work, and then graph it, and then find some clean points. And we would, if we did graph it correctly on a perfect graph, we would see that you rise 4 and run 3, and we'd get that same slope. But it's a lot faster to just know slope-intercept form.